the bonus track for the graduates and anyone else who really wants to take full advantage, no matter what happens here, of the fact that you don't get credit in the new world for nice job putting your name on the sheet of paper. So let's look at, and we'll nail down the number later, 390 math facts in pictures. So let's start with not the unit circle, but the trig circle. Do it kind of a circle here. That math fact of x squared plus y squared equals 1 squared. The fact that the sine divided by the cosine times this hypotenuse is equal to the tangent. So this is the sine. This is the cosine. Of course, all that follows from that, the area of that circle, the angle, total angle, is 2 pi, total area equals pi. There's a lot more that comes through there, but if this in fact is theta, then that angle there is theta over 2, and that area is theta. So there's a lot of facts that come out of that one. We won't put numbers on it. You remember the secant, the cosecant, the cotangent, lots that comes out of that. But that's the trig circle. Now on, of course, to the unit circle. And I'm going to just present this in the most basic way to know it and then start flipping it. And that is not that what you know. We'll do that off on the side. We know 0, 1 over 2 over 2 over 2, and then 1, 0 over 2 over 2 over 2, 1, 2, 3, 1, 2, 3. Square roots on everything. But remember, the square root of 1 is there. Knowing the tangent of 45 is 1, the tangent of 60 is the square root of 3, and the tangent of 30 is 1 over the square root of 3. That is not finally how to probably grab the unit circle. In all its glory, you just grab, I'm sorry, I'm going to try to take this out. You grab the pi over 4, the pi over 6, and in fact the pi over 12. And you learn that there is a lot of flipping that goes on. So you know that this is, in fact, if you want to grab the numbers, 0.7071 twice, 0.7071. If you want to grab the numbers, this is, of course, is more in the x, 0.866 and 0.5, and this one is 0.9659 and 0.2588. Remember that this flips down, flips over, and then flips out again here. So this is a mirror image. So you have a mirror image. All right, so number of math facts there, I'm going to say about 80 when you get it down to the pi over 12 and everything else. So we're going to go now. So there's 2 circles that get you a lot of information, and that, in fact, maybe not completely facts, but awfully close to be able to not have to go and dig deep, that you can kind of think things out. It helps you to go through the geometry and the trigonometry when you're doing that. All right, so we had, just to review up on top, we had 1 was the trig circle, 2 was the unit circle, and 3, we'll just talk about it being graphs of functions, graphs of trig functions. And the 3 together get you that redundant system. If you look at this here as going from 0 to pi to 2 pi, you know that the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, and so you have the sine wave doing something like this. You know that the cosine of 0 is 1, the cosine of pi over 2 is 0, and the cosine of pi is negative 1, so you have this here. And as you remember, let's see, home. Let's see, I don't want to lose that here. I'm going to go down. Hopefully I didn't lose that. All right, you remember that in fact you can get a lot more. I'm going to go this again. This is the cosine out of phase, right? So you got the sine and the cosine, this being the sine and this one being the cosine, and the fact that the derivative of the sine is the cosine, and the derivative of the cosine is the minus sine. That takes you pretty far along to a lot of the other things that we talk about in terms of the tangent coming up. Tangent is 0 here, and a tangent of 90 being 0, so you kind of have a function, you remember, that goes up like this. And alright, so there's 3 pictures, probably easily over 120 facts in those 3 pictures. This picture here, a transformation matrix, where in fact you stack up your variables x, y, z with a 1 chaser, dot, dot, dot. Now x, the nth x, the nth y, the nth z, now that you're through things, and that you put things here, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, and that in fact you translate with those, you scale with those, and you do your rotations by locking up and saying cosine minus sine, sine, cosine, except when you're locking up the middle and then you switch the sign on the sines. This works equally well for x, y, z, or northing, easting, elevation 1. Northing, easting, elevation 1. So this works equally well if in fact you realize that the easting is in the second one. So there you have a lot more facts. That essentially is a lot of coordinate geometry. COGO that you see somewhat in survey class. That does all your transformations, your scales, and then it also does your animation. We'll move on, hopefully. We'll keep this down to a really short and then fill it in with the actual facts later. Those pictures. We're going to go now to the fact of the units with circle, which somehow, some way, some form should have been drummed in our heads a lot earlier and better, but it wasn't, and so you're fine, because learning to carry some of these things out the door, doing this based on knowing the unit circle is where we really got to a point here where we know we're going to divide this up. And very quickly, if you start perhaps with something, instead of going around the circle with specific gravity, always traveling with unit weight, and realizing that force here is up on top, and then we have angular displacement, distance, area, volume, and then mass. So if you think 1, 2, 3, 4, 5, 6, that takes you there, going from force to work to power to pressure to torque to density, and once again 1, 2, 3, 4, 5, 6 in 15-degree increments. Then I'm not going to go through them all. You should at least know that cubic meters and square meters, cubic meters, square meters, or meters, or cubic feet, square feet, and feet, and then start to know acres and hectares. Mass, you should know kilograms and slugs. You should know force being pounds and newtons. You should know work being joules or foot-pounds. You should know power being watts or foot-pounds per second. But then, of course, horsepower as well. Pressure, pounds per square foot or pascals. Sure. Pounds per square inch, kilopascals. Sure. Torque, newton meters, pound feet. Density, slugs per cubic foot or kilograms per cubic meter. And then unit weight, newtons per cubic meter. And of course, pounds per cubic foot. In that, you probably have another, if you think about it, you've got very easily 13 times easily probably 4. So you're looking at around 60 facts in one picture. So we'll leave it almost at that. We're going to go with one more to keep this at less than 15 minutes. But what this was specific gravity and unit weight holding up the sides. You've got force holding up the top, and then unitless. Then distance, area, volume, mass, up to force, knowing that mass times acceleration equals force, force times distance equals work, work over time equals power. Pressure is both force over area and energy per cubic per volume. Torque is newton meters, knowing that torque times theta, or angular displacement, is work. Density, mass per volume, and unit weight, weight per volume. Knowing that density times G equals unit weight comes up a lot. So you have to realize that density, mass density times G equals unit weight. Why is that? Mass density is mass over volume. This is G. Mass times acceleration due to gravity is weight over volume. So we're going to go and move on now. One more. We're going to go to stress strain, to the survey circle, to some whale, even though that isn't part of the overall bit of this. It's worth it. It's the same as the unit circle or the trig circle, but it's worth looking at it so you can get accustomed to working on the left hand system. So stress